Hey there and welcome to the Code Wrinkles channel. In this video, I would like to show you what the process of designing or architecting a microservices solution might look like in real life. And yes, I know I said it plenty of times that microservices are evil, and whenever we need to start a new project, let's not start it from microservices. I even created a meme that went pretty viral on X, or the former Twitter, and a lot of people agreed that, well, microservices is in most cases not really a way to go. However, as developers, we need to know the basics or have a basic understanding of microservices architecture or microservices solution, even if we hadn't had the opportunity to work with them. Because, well, that happens, we will probably get asked about it in interviews. So Code Wrinkles will have you covered also for that, because I'm sure that the main question that you might have is, okay, let's go for microservices, so where do we start? And these difficulties come from the fact that you are actually not exposed to the entire process that happens when a new project, let's say based on microservices, would have to start. So let's try to fix it. Usually whenever you start a new software project, no matter if it is on microservices or not, or it's a monolith, it has what we call a discovery phase that includes a lot of different aspects or a lot of different steps. And along the way, you gather enough information to actually create a basic overview or an architecture of the system that you want to build. That goes also for microservices. And one of the first steps that we get here is, for instance, the requirement gathering. And what would usually happen in this case is that you would have probably a lot of different product owners, product managers, BAs, talk to the business, do a lot of interviews, and create a basic overview of the main requirements that the application might have. Now, this information is vital because as an architect, for instance, when you need to make some decisions, you make those decisions based on this information that you get there. However, for learning purposes and in this video, I really cannot replicate that. So what I have done instead, I have used the GitHub Copilot with the new Claude extension, and I have built this very basic UI in virtually 7 minutes. In our case, graphically, those requirements would look like that. So here we have some functionality that we can see explored here in this left navigation, like the home, explore, notification, messages, lists, profile, and so on and so forth. We have here the main section where you then create posts. You can see then have you then have a news feed where you see the different posts that were created by others. So you already have kind of like an overview about the functionality that this application needs. Now, the next thing that happens after you have all this type of requirements is that you need to start, let's say, a domain analysis and boundaries definition. So what you need to do is kind of like, okay, say these are the requirements. Now, how do I technically, or how do I define the different boundaries, the different logical boundaries in which some business transactions or business operations happen? And how would I actually do that in my application? This might seem very easy in all the examples that you find online with an e-shop where you kind of like have a shopping cart and the ordering and the invoicing and everything seems to fit together. But how do we fit this idea together here in an application where we don't really obviously see it from the first phase where exactly these logical boundaries might be? So the question that I would ask to myself in order to define and understand where are those logical boundaries is, let's try to understand and find units of behaviors that kind of like almost always go together in some sense. Like together they build some logical unit that performs a certain task in the ecosystem of the entire application. And if we take a look at what we have in this UI, I said this is a reference of the requirements that we have gathered or that the team has gathered throughout the first phase of the discovery. And we have here a home. Obviously, that's kind of like, okay, the home page, but it's what is displayed here. But that doesn't really help us much because that's actually an aggregation of different things from the application, like from the profile, from the newsfeed, from the trending. So it's not really defining a logical boundary, for instance. But if we think a little bit here, okay, we can start and say if we are here at these notifications. Like this idea of, okay, whenever something happens in this application, a user might receive a certain notification and the user should be able to see those notifications. So this might be kind of like a behavior, a unit of behavior that kind of like behaves or belongs together. And therefore, this could be a first logical boundary of our application. And then we see these messages. Once again, users might send a message to another user, that user can reply to that message. This also seems like an island, let's say, of pretty much isolated functionality that is aimed to perform a very specific business objective. In this case, just messaging or enable messaging between the different users. So this might be a second logical boundaries. These bookmarks could also be such a logical boundary. And then this idea of lists, like I want as a user to create a list of different, I don't know, users or types of posts that I want to see, basically on different topics. That's once again seems to be a very isolated functionality that performs a very typical use case in our applications. So this might be another logical boundary. Now, the profile of the user, editing the profile and everything also seems to be pretty much self-sufficient or self-contained, and that's why this might be another logical boundary. But then we have here the entire news feed, like what I see as a user. Now, that's a whole universe behind this idea of creating a news feed, so that's another logical boundary for my application. But then what am I able to do as a user? Well, I'm able to perform posts or to create posts here that could have pictures, videos, whatever. That's not really important. So the ability of posting and managing posts and comments and likes, because as you can see, you can like posts, you can repost posts, you can reply and like. This is actually the like. So this is another logical boundary of our system. And the idea is that we could extract this logical boundaries basically into microservices. But there's also a next step to it, because not everything in the application or in the entire system will be kind of like a logical boundary of an application. For instance, we have here in the profile, we see that it's missing right now, but we have this idea of profile images, okay? Cool. So what happens with them? I need to be able to upload profile images, maybe to display them then afterwards. So this is not really a logical boundary of the business of this application, but it's still something that our application needs in order to support everything that's needed or that the business needs here. And that's why we might have other types of areas that we might call supporting services. And here, for instance, we will have a file upload. Let's make this a little bit smaller. But then, for instance, when you log in or you log out or you want to reset your password, or if you want to have two-factor authentication, then what happens is that you need another supporting service here or functionality, which is emails. You need to be able to send emails. And if you think, once again, from the requirements that you will get, or the entire project team will get during this first phase, you will have a very good idea of what are these supporting services that you need. So in the second step, you as an architect will have to define all these type of logical boundaries of the application or the business of the application itself, but also the supporting services that you might need. Because guess what? In the end, all of them will be candidates to become a microservice. Now, once you have this clear overview about the functionalities and this very rough idea about the services and supporting services that you might need, then the next step is to, okay, what is the technical feasibility and what stacks should we use for the different services? And here you might try to already look into what knowledge does exist in the current company or in the teams, how things are set up, are there any, I don't know, maybe licensing commitments or legal commitments to different products or companies. So there are really a lot of different things that might play a very important role in defining exactly, okay, what's technically feasible and what stack should we use for the different microservices or for all microservices. And after you've done this, the fun part really begins from my point of view, because afterwards, it's the point where you actually need to start to really design your microservices architecture. And you see, till now, nobody actually writes any code. This is all the design and architecture phase. And that's the part usually when architectural diagrams come in. What I like to do, or how I like to approach this type of steps, is usually to always start from the C4 model, because there I can really start from a very high level overview of everything that needs to be done, like from the system context diagram. And the system context diagram would look like, obviously it's a very simplified version here, but it would look something like this. So we would define that, okay, we have a variable user, that is the person, the user that uses or that interacts with our application. I also like to maybe add some very basic idea of the core functionalities or the things that the user can do in my system. Now, at this point, I don't really care to really be explicit in the diagram about the technology stack and everything else, but I just want to kind of like define where exactly the entire system might fit into the existing organization and existing other systems. The core idea here is that here we have the system. This is the best microblogging platform in the world, and we call it Warble. Now, the important thing for me is that I've defined earlier that I need a supporting service. So I will probably need an email service for that. That's the point, like when you do the system context diagram, when you think about all the integration with all the external systems that your application might need to have. Now, external systems, the way that I look at them are systems that kind of like are already built, that are already there, and that you can just use, but with minimal configurations. You don't have really a lot of freedom. For instance, I don't think about a database, let's say, as an external system, because the database, you can shape it yourself. You can define the tables, you can define the structures, whatever. You can do a lot of stuff. But when interacting with an email service, well, you just know that you need to kind of like send or make a call to the service with a certain body or in a certain way, so that the service can actually send out an email. And you cannot really configure that much. You just need to apply or to obey the rules that that service imposes. And this is the point where you need to really lay down and have a very good understanding of all such external systems with which your system needs to integrate, because this gives a very, very good overview about all the dependencies and the technical difficulties that might arise from integrating with those dependencies. Because with some dependencies, the integration might be easier. With some dependencies, the integrations might be a little bit more complicated or even risky or even not possible out of the box, and you would have to design dedicated solutions for that somehow. Now, after we have a system context diagram ready and we know all the external dependencies and integrations, it's the point to actually zoom in one step and actually try to understand exactly how our application, how our system looks like. So what are the different, let's say, containers or applications or subsystem of the system that we try to build? And that's where the container diagram actually comes in from the C4 model, where we still have the user, but now we try to model basically what we have or our system, which are the different moving blocks of our system. And when I think about moving blocks, I think about, well, let's call them containers or components that run on themselves, like that are standalone applications, that are standalone processes. So here is where we'll define exactly what our services are, how do they communicate with each other, what databases do we use, how do we make synchronous or asynchronous communication. So we would lay down everything here in this container diagram. In our case, what could be a very, very basic approach is that we have a Blazor web application, and this is the entry point for our system, like the user interacts with our Blazor web application. This then needs to connect somehow to all the different services that we have in our system. And usually what will happen is that you will use an API gateway, and there is a totally different discussions about what's a reverse proxy, what's an API gateway, what's a backend for frontend, and I won't go into discussion right now. So for now, let's just assume that we just have this API gateway. So our Blazor web application, which is one standalone application, like a container, communicates through HTTP calls and using JSON with this API gateway. And also we see that actually we also have a bidirectional communication between the gateway and the Blazor web app through WebSockets. And we'll understand just a little bit later why this communication is actually needed. Now, the API gateway, as you see, it has different relationships. It has a lot of different dependencies because it calls all the other services, like the user or the web application calls the gateway aggregates the response that's needed to actually return to that specific web application. So first of all, we have this Cerberus, which is the identity service. Let's call it that way. And this identity service has its own database. Here we also go into the technologies that we use. Here we want to use Microsoft SQL. We definitely want a relational database for that. And we also have the message bus. So we know that we have a message bus to enable asynchronous communication between services. And our aim is that all our services should communicate with each other through messages in an asynchronous way. So that's why we have this service that also kind of like emits messages to the bus, but also consumes messages from the bus that might be emitted from other services. Then we have the profile service, and it's the same way. It emits messages, it consumes messages, and it also has a database. But for instance, here, if we just want to store profile information that's not really highly relational data, So here I might just want to use a document database, so we might go for a MongoDB. Then we have this post service. Once again, it connects to the message bus. And by the way, the message bus itself, it's an application that runs on its own independently, so it is also considered a container. And here this post service also has a posts database, and we have also the newsfeed service that also has a newsfeed database. However, for the newsfeed part, things might get a little bit more complicated, because if you really want to do very fancy stuff with newsfeed generation, you'll probably also need a lot more carefully designed data approach, because you might need to aggregate data from different sources. And last but not least, here in this very basic setup, we have this Herald microservices that also this service just consumes messages from the message bus, because what's the responsibility of this service? Well, that's a supporting service. This service just sends emails. So this service is the only one that knows exactly how to integrate, how to interact with this external system. And in our case, we can even define the technology at this container level that we might want to use SendGrid to send emails, or we might want to use something else like a regular SMTP server. Maybe we have an in-house SMTP server. So that kind of like depends on the requirements, but this is the only service that kind of like knows about this integration and how to send the emails. So the idea is that probably our identity service servers will have to kind of like, well, when we'll emit certain messages, for instance, when you want to reset a password or something like that, then this Herald will just pick into those messages and will send the appropriate emails that are needed in order for the user to reset his password or perform multi-factor authentication, and so on and so forth. Now, just for learning purposes, when you've done this type of diagramming, is the point where you can start thinking about, okay, I would like maybe to create a solution, maybe a .NET Aspire orchestration, in which I want to model all my microservices system according to the architectural diagram that I have here. And if you want a dedicated video on how we can do that, like how can I take this architectural diagram and replicate it practically in a .NET Aspire orchestration project, please let me know in the comments. Also, make sure that you hit the thumbs up button and share this video if I see that there is really a big interest in such a potential video. I promise you I will do that. So for this video, I will stop here, because that's already a first step where we can do something very practically and see how we can map the architectural diagram into a .NET Aspire orchestration. However, the discovery phase usually continues with a lot of other very important topics, which, for instance, you need to define a data strategy and design. Then obviously there needs to also be a security and compliance analysis, and that's also something that you as an architect will be probably responsible for it. And by the way, if you are in a setup where microservices are really needed, you will not be the only architect working on this. Like doing all the discovery phase and all the technical work that's needed to do everything that's basically here on this slide requires a lot of time, and you couldn't really do it alone. So you will probably have a lot of other colleagues, and you will probably each one of you will do different parts of the discovery phase or subparts, and well, depends how you actually organize yourself as a team. But also during the discovery phase is where we need to plan for scalability and performance considerations, for elasticity. How do we need to scale? When do we need to scale? Things that have a higher priority to scale. Is the Kubernetes autoscaler enough? Do we need maybe some software-defined autoscalers? So really, there's a lot of things to think about also at this point. Also, not to forget the operational and monitoring strategy for each project, especially for microservice project, you need to have something like this in place. And last but not least, also a risk assessment and mitigation planning phase, where you want to understand exactly, okay, what are the risks, and if certain risks occur or problems happen, what are the mitigation plans? Like, you need to have this in place in order to have a robust kind of like application ecosystem. Otherwise, when something goes wrong, nobody knows exactly what to do. So these things should be planned in advance, at least those that can be planned in advance. Obviously, in practice, you'll see that probably things will happen that nobody did think about, but the important thing is to reevaluate this always, and whenever something new occurs, to also add this to the risk assessment and the mitigation planning for that specific project. That's quite it. In this video, I just really wanted to walk you through what a process of designing and architecting a microservice solution might look like in real life, based on what we call the discovery phase of a project. And remember, this is a phase where usually no code gets written, but it's the most, or one of the most important phases of the delivery of each project. And also we have looked into how we can take the requirements that we gather during this phase and also translate them into logical boundaries that might define our microservices, and then also identifying supporting services that we might need. And last but not least, how we transpose everything in some architectural diagrams that can serve as a baseline for the teams to actually start working and implementing the approach or the architecture that you as an architect have defined. If you have enjoyed this video, don't forget to hit the thumbs up button and share it with your friends that you might think that they might be interested, and I am sure that they will be thankful to you. Also, if you're not subscribed to this channel, please hit the subscribe button and the notification bell so that you are always notified whenever something new happens on this channel. And if you want to get in touch with me or just have a question, don't be shy and head over to the comment section and leave a comment, and I would be more than happy to get in touch with you. This being said, thank you very much for watching, and until the next time, I wish you the very best.